Welcome back, ladies and gentlemen. We're going to be taking a look at our first section of our three-dimensional objects, and we're going to be discussing surface area. So some quick vocab to start off with. We have three-dimensional shapes. We call these solids, okay? That means they have a third dimension, like length, like width, and a height. When a solid is formed by polygons, the solid is called a polyhedron. The plane surfaces of a polyhedron are called faces. The segments joining the vertices of a polyhedron are called edges. The two bases of a prism are congruent polygons in parallel planes. Okay, we're going to be going over that. That's probably one of the toughest ones for today. And the base of a pyramid is always a polygon. All right, so let's put all that together like we quickly read through it. Right number of faces, vertices, and edges of the polyhedron. So faces, vertices, edges. Okay, faces are basically your polygons on the outside. So you have one on top, one. You have one on the bottom, two. Now see how they're parallel? Like triangle A, B, C, and D, E, F, those are your bases, okay? So 1 and 2, 3 is in the front, 4 is on the side, 5 on the back. So 5 faces. Your vertices are actually just your points, your corners. So 1, 2, 3, 4, 5, 6. There's 6 total. And then it leaves us with edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 9 edges. Very good. Okay. Identify the shape of the cross section. So here we have a polyhedron. Okay, we have a cone, and we are cutting through the plane. Well, the cross section is the shape that is formed when you cut through it. So in this case, that is going to be a circle. Okay. Over here, we've got 1, 2, 3, 4, 5. So 5-sided shape. Pentagon. All right. Now, for all polyhedrons up here, we have faces, vertices, and edges. Well, we can also take a look at down here is we have a formula that can relate all of them. We actually call this Euler's formula. He's a brilliant mathematician. We'll talk about him someday. But basically, the formula is just faces plus vertices equals edges plus 2. So we're going to take a look at 3 examples, plugging in where we see what we have and trying to find the missing one. A pyramid has 9 faces and 9 vertices. How many edges does it have? So we've got F plus V equals E plus 2. F plus V, so in this first problem, we've got 9 plus 9 equals E plus 2. I knew I had 9 faces. I knew I had 9 vertices. I don't know how many edges I have. So we're going to solve this. 9 plus 9 is 18. Okay, subtract 2 from both sides. So 16 edges for part A. Nice and easy. Simple equation. Part B, a prism has 8 faces and 18 edges. How many vertices does it have? Okay, so 8 faces. I'm going to go over here now just to kind of spread them out. 8 plus V equals 18 plus 2. All right, so 8 plus V. Oops. Pardon me. Updating my computer. And then over here, I've got 18 plus 2, which is 20. All right, I can subtract 8 from both sides. I get 12 vertices. Okay, very good. Lastly, a polyhedron has 15 edges and 7 vertices. How many faces does it have? Well, F is the one that's missing here. So F plus, we've got 7 vertices equals 15 plus 2. Okay, F plus 7 equals 17. 10 faces. So again, not a terribly hard equation. It just kind of relates to the faces, vertices, and edges to one another. Okay? Wonderful. On to the back. All right. So we've got surface area. Now, we've kind of already discussed surface area in class, so it's kind of neat. It's going to help us out. But basically, it's just all your areas on the outside, the exterior of your polyhedron. Okay? So we do have a formula. 2 times the area of the base plus perimeter of the base times height. All right, this will be provided to you. You just have to know how to use it. Now, we get kind of lucky on part A because we talked about the base being parallel to one another. Well, in this problem, I mean, you can literally pick what you want. I'm going to pick the top part and the bottom part to be my base, okay? So it says 2 times the area of the base. Surface area equals. Now, the area of a square is side times side, so 6 times 6. Cool, that's all that's saying. There's my area of my base, plus perimeter of my base. Guys, it's a square, so 6, 6, this will be 6, this will be 6. So I'm literally adding them all together. Some of you might be thinking, can I just do 4 times 6? Absolutely, all right? And the height of your polygon is the distance between your bases, 8. Cool, show that first step. Once you show that first step, now I'm gonna put everything right into the calculator. Okay, and then times 8, boom, 264. Now, please be careful. It's 264 meters squared. Units are one of the most important things with this problem, okay? So please be careful. To the right, things get a little bit more difficult. Surface area, okay, 2 times area of the base. Well, my base is the triangles in this problem, all right? So I need the area of a triangle, which is 1/2 base times height. So 1/2. So here's my base, here's my height. Please be careful that 15 is not needed for my area, but I do need that for perimeter. So 1/2, 9 times 12, plus the area, or sorry, the perimeter of my base would be 9 plus 12 plus 15. And then the height between the two, 10. Okay. All right, where are we at here? Good stuff. So we've got 2 times 1/2 times 9 times 12. Okay. Plus parentheses 9 plus 12 plus 15 times 10. 468 centimeters squared. Great. Okay, looking good. So now we're going to move on to, okay, it's just a lot of formulas today. I hope you guys are noticing that. It's not crazy over the top. Surface area of a cylinder, 2 times area of the base plus circumference of the base times height, or 2 pi r squared plus 2 pi rh. Hopefully you guys are comfortable with pi being the irrational constant, okay, and r standing for your radius. H, of course, again, is your height. So surface area, these are my favorite because they're just very simple. 2 pi r squared, my r in this problem. Guys, here's your circle. The radius starts in the center of your circle and goes out. So it's 5 squared plus 2 times pi times my r, and then my height is the number that's left over, 2. Here's the deal for this one. If I do this, okay, 5 squared is 25 times 2 is 50. 50 pi, plus over here, 5 times 2 is 10, times 2 is 20, 20 pi. I would like to encourage you guys to write your answer in 2 ways. The first is just to write it as pi. The second is to actually write 70 pi in your calculator and get 219.91, 2 decimal places. 91 yards squared. Why do I want to show you that? As you guys progress further in math, when you guys get to Algebra 2 and possibly pre-calc / honors pre-calc, you're going to need to know, you're going to have your answer written both in pi and also with decimals, okay? Cool. Tricky one for the next one. All right, we've got 2 pi. My radius here is going to be not 8, but 4. Okay. Plus 2 pi. My radius again is 4. My height is 6. Good stuff. All right. 4 squared is 16. Times 2 is 32. 4 times 6 is 24. Times 2 is 48. Okay. 50. That'd be 80 pi. Or, okay, 80. Oops. 80 pi, 251.33. Okay, inches squared. All right. All right. Good stuff. So we're down to our last 2 shapes then. All right. The first is a pyramid. Is a polyhedron in which the base of a polygon and the lateral faces are triangles with a common vertex. Okay, you guys have seen a pyramid before. A cone has a circular base, right? And a vertex that is not in the same plane as the base, okay? And lastly, the blank of a pyramid or cone is the perpendicular distance from the vertex and the base. This is just your plane height, all right? Now here's the important thing for you guys to realize. This is the trickiest part of this. The height goes straight up and down, all right? The slant height, which we're going to talk about, goes down the side of your pyramid or cone, all right? So we're going to have to use some good old Pythagorean theorem for these. So we're down to our final 6 problems here. Okay, you guys doing great. Okay, thank you for hanging in there. So we're going to take a look, find the slant height of the pyramid or cone, round your answer to the nearest whole number. All right, so slant height is this distance. All right, so basically, guys, what I need to do is I need to use Pythagorean theorem. Okay, this is going to say if I have a right triangle, A, B, and C, A squared plus B squared equals C squared. So in this problem, we're doing 7 squared plus 12 squared equals, I don't know, we call it x squared. Okay, so we're looking at 7 squared is 49, 12 squared is 144. Okay, good stuff. If I go ahead and add those two together, so 49 plus 144, okay, we get 193. Good stuff. I'm going to square root 193 because the opposite of squaring something is to square root. And if I do that, 13.89. That would be in centimeters. So what that distance is telling us the distance from the top to the outside of my cone or my circle for my base. Okay. Please be careful on the next one. We were lucky they told us this was 7 right here, okay? But for the next one, we're not so lucky. For this next one, the entire base going across is 10. So guys, what do you think this distance is going to be? Okay, well, it's going to be 5. So here, now I've got 5 squared plus 8 squared equals x squared. All right, they're going to try and trick you every now and then. 25 plus 64 equals x squared. So again, back to my calculator, 25 plus 64, we get 89. Okay, the opposite of squaring is the square root. Square root 89, I get x equals 9.43 meters. And notice that we're not doing meters squared here, we're just doing meters because we're finding that distance, not the actual surface area, okay? All right, I'm going to hit the pause button for a moment. I will be back with my next video for 7, 8, and 7 and 8. Hopefully this is kind of sinking in a little bit. Feel free to ask questions as we go through it. Guys, keep up the good work, and as always, good luck. We're all counting on you.